All right, so today's video is to do lots more normal distribution problems. The only thing you've seen so far at this point was that 6-part one about cars, miles per gallon. So make sure that you have repracticed that. This video is gonna do those 6 problems from handout 9. If you have not tried those on your own yet, I do not want you to watch this video yet. I want you to go try those. That way, if you've gotten them wrong, when you watch me explain it, it will be much more helpful to you and you'll be able to see where you messed up or, the issues you're having. I did not post notes for this video because basically there is the answer key to handout 9 on Canvas. I just know sometimes it's more helpful if a student is struggling to listen to me actually walk through the problem. Also remember, for test 2, you are not doing all of handout 9. I gave a very specific assignment in that particular video, and it's also listed on the homework sheet. There's only certain problems from handout 9 that you're responsible for test 2, because the rest of them are test 3 material and you will really confuse yourself. Also, make sure you have out, this is the Z-chart. This is the one that I will be using throughout my entire course. This is the one that you'll be using on tests and exams, that type of thing. All right, let's start. So this is assuming you've practiced them. Let's start with 5A. Excuse me. All right, how much soda is in a bottle? You buy a bottle, it says there's 355. I doubt there's exactly 355, right? Just from a quality control standpoint, might be a little bit more, might be a little bit less. From past experience, it has a normal distribution. Okay, so that's the key that we're doing this technique. So soda is normally distributed. 355 is the mean. 2 is the standard deviation. So I'm just summarizing the problem like that so I don't have to keep reading everything. Part A. In Part A, Part A is the only one from number 5 that you're supposed to be doing for test 2. What is the probability a randomly selected bottle has greater than 340? Okay, let me draw a quick little picture. The mean's 355. We're doing 340. We want greater than. So my picture reminds me, and if you draw the picture and actually use your picture to check your work in about 2 minutes, this picture is going to catch a lot of wrong answers that I see on a problem like this on test 2. Because I know my picture is telling me my final answer better be greater than 50%. All right, so we're doing x greater than 340. Because these are the x values, right? This is that milliliters. Okay. We don't have a chart that's centered at 355, right? So we have to standardize this. So maybe I should back up just for a second because you may not have done this in a while. It says, what's the probability? It's asking for the area, right? And that's what I colored in. It's giving you the x. So we know we are going forwards. It gave us x. It's asking for a. So of course we have to go through the z. All right, how do we get z's? We always subtract off the mean, divide by standard deviation. Some of you use the wrong z-score formula on test 1. Make sure you have the z-score formula correct. This is z greater than. I'm going to cheat and use my answer key. Negative 7.5. All right, we are not done yet. But you know how I keep telling you to draw a picture and it will help your brain? On this one, we might want to update our picture, right? Because apparently, remember when I drew my picture, I didn't know what the z-score was. Now that I've calculated the z-score, I'm like, oh, the line is not there. Negative 7.5 is actually off the chart. Now I know that this must be the boundary. Somewhere off the chart, right? So I'm really looking for that. So I'm just kind of updating my picture, right? Because I didn't know exactly what to draw until I did this step. Now, first time I approached this on one of the videos, how to read the Z-chart video, I talked about there's two ways to do this problem. If you know you were off the chart and you've drawn your picture correctly, you obviously know the answer is 100%. Okay? Having that conceptual understanding, I want every single person to have, right? But I know some students may not be there yet, so let's do it a different way. If you're not quite catching drawing the picture, how you're supposed to know that negative 7.5 is off the chart on the left-hand side, that it asked greater than, so obviously I just colored in the whole curve. Let's do it a different way. You cannot look up negative 7.5 on your Z-chart, right? The smallest number you can look up is negative 3.89. So I'm going to just put that in parentheses. You can go look up negative 3.89. When you look that up, you will see 0. And at this point, you might be confused. Wait, I thought she said the answer was supposed to be 100%. Yeah, but remember, I would like another color. Hold on. Remember, it's a greater than. Remember how I've been organized the whole time? I've been carrying around that greater than symbol so I don't forget that this was a greater than problem. Remember, this chart, and this is what the little black coloring at the top means, it's reminding you that this chart is giving you less than areas. We want a greater than area, so we have to subtract from 1. 1 minus 0 is 1 in decimal form, representing the unit whole, or 100%. I do not care which way you write the answer. So you can attack it intuitively, or by playing with and using the chart. So the answer is 100%. All right, let's do 11B. Um, 11A is a fine problem. You guys can do that. It's pretty easy, but 11B is the one that sometimes students get wrong. This is about, street lights, the light bulbs that, they have on street lights. Let's see. Mean, normally distributed, so how long do bulbs last? 400 days is the mean. Standard deviation is 30 days. Maybe I'll just put my variable so I remember that's in days. All right, we're doing part B. 95.15% of our lamps last at least how many days? So, it just asked me how many days. It gave me, I'm just kind of identifying what's in the problem right now, right? It gave me something about the 95.15%, and it asked number of days. This is absolutely a working backwards problem. But remember, on the working backwards problems, if you put no thought into it, you have a 50% chance of getting it correct. We have to think about the problem before we ever get into it. Because on the working backwards, I always wonder, am I going to look up the 95.15% or am I going to look up the opposite, the 4.85%? How do I know? Well, let's draw a picture. And the biggest theme of mistakes throughout all of test 1 was the word at least. I don't know if you noticed on test 1, I think it came up in probably at least, no pun intended, 3 different problems. So you have to truly understand in your soul that at least means go bigger, greater than. Remember on these normal distributions, I don't really care that it's that number and greater. When you're doing probability, which will be the next video I make, and I'll remind you of this, when you're doing the probability problems, it's critical you remember that at least does include that number. But when we're doing the normal distribution, all we need to know is that it means go greater. Okay, back to my problem. I talk too much. Okay, 95% last at least how many days? Let me put my mean. I have to put a boundary where I'm going to have, for right now while I talk about it, I'm just going to call it 95%, okay? That I'm going to have 95% bigger than it. If you were struggling with this on this problem, I'm going to show you how I really recommend you do it. I'm going to take the luxury of using different colored pens. You only have two choices. The boundary is either going to be on the right or on the left, okay? Draw both of them right now. Now let's look at each one and ask ourselves, what makes sense? Which boundary has 95% bigger to the right? Oh, no, that's a tiny bit. There's no way that's 95%. Oh, yeah, that looks like 95%. Okay, so he's wrong. Look, that looks pretty good. That looks like 95%. There's my picture. Why is that picture so critical? It tells you two things that you're about to make a mistake on. It tells you, in just a minute, when I get my z-score better be negative. If you end up with a positive z-score, you've done something wrong. It also tells you as a final answer to 11b, your answer better be less than 400. If it's not, you've done something wrong. So there's a lot of checks and balances. The whole point is, I should label, sorry. Right? That's the 0.9515. Unfortunately, remember this piece of paper that rules my life? This piece of paper does not want to know who lives on the right side of the fence. See, I always call this my little fence, right? It's like in a neighborhood, you know? I actually have a fence between my house and my neighbors. It's like I live here, my neighbors live here. This chart does not want to know who lives on the right of the fence. It always wants to know who lives on the left of the fence, the less than area. So, remember the entire curve is 1, or 100%, but I'm in decimal form here, so I'm going to talk about 1. So you have to go 1 minus 0.9515 to figure out that this is the area I have to talk to my chart on. This is my area. I can tell this one is so precise that when you go look it up in the chart, you really will find it. Remember the areas, I always said I was going to wave to you, is in the body of the chart. These are the areas. So let's go find 0.0485. This is small numbers. 0485. Just give you some idea if you're struggling. You can kind of see where my finger is pointing. 0485. So now I've got to get the z-score. Go over to the left and up to the top. Negative 1.66. And there's that negative. Of course I was expecting. Okay, so I'm doing good so far, right? Equals, I don't know what x is. I know the mean. I know the standard deviation. This is the z-score formula. There was, on one of the questions on test 1. I don't remember it now. But that is why I put a very similar problem. It's just the numbers were different on test 1 to make sure you understood what the z-score formula was, that you could use it like in a backwards way. You could do the algebra. So you may want to look back on test 1 to make sure that you got that problem correct. Now you use your algebra. Again, I'm going to cheat and go to my answer key. The answer is 350.2. It's not 350. We are being precise. 1 decimal place is plenty here. This is not a number less than 1. And that makes sense, right? Because I knew I had to have a final answer less than 400. Now, I wrote days. Here's where I cannot make all of you happy. If I don't write the word days, my science majors start emailing me, do we have to write the units? I'm like, no, you don't. But I try to write that to make them happy. So on a test, I'm just happy if you write 350.2. You can put the unit if you want. All right. I think I've discussed most of the issues I see students have. The biggest issue is students don't draw the picture. They read 0.9515, they go to the chart, they end up with the positive, and then they end up with like 450 or something, and it's totally wrong. You can't just see that number and go straight to your chart. You saw most of our thinking occurred before we ever started the problem. All right, let's go to number 9. I tried to pick the problems that in general students have through the years always asked me to do in class. Oh yeah, number 9, there's a couple of different ways we're going to do this. Okay, psychology instructor makes sure that every set of exam scores, test scores, normally distributed. Then she assigns A grades to the top 15%, bottom 15% are Fs. Okay, so I'm already getting the idea that they're giving me areas. So I know it's going to be a working backwards, even though I haven't even finished the problem. But maybe as we go, I'm going to start drawing the picture. Top 15% get A's. So really, if you want to think about it, that's the AB line, right? Bottom 15%, and please, 15% is 0.15, are F's. So I guess that we could call that the FD line. I think the first confusion on this problem is some students overthink it. We're not going to be able to figure out who gets a C and that type of thing. This is all we are figuring out. Now, at first glance, it does look like we have 2 different problems. We sort of do, but I think we're going to be able to take a shortcut in a minute. Maybe I should keep reading. Set of exam scores turns out to have a mean of 60, standard deviation of 16. So the scores are normally distributed 60, 16. And then it's just basically asking, what are those test scores, right? 60. So I guess I could put 60 in here. Okay. Now, I want to talk about this before we ever get going. I'm going to be able to take a shortcut. How do I know that? Why do I know that? See how, remember this whole curve is symmetrical, right? We started talking about that even when we were just doing the generic empirical rule, okay? So if you have 15% in each tail, I know there is symmetry. This z-score for that line is going to be the exact same z-score for this line, except this is going to be negative, that's going to be positive. And I'll show you that in just a minute when we're doing the problem. But let me say this. If they had said 25% A's and 15% F's, in that case, you have no shortcut to do. You just have 2 totally separate problems to do. But we're going to be able to cheat in a minute. So with that said, you want to think about which tail is easier to work with. Because we've got to start somewhere, right? Remember this guy? Our life is ruled by this. This chart always wants to know who's on the left. Less than. So this is the easier tail to start with because it's already a less than area. All right. So let's do that. We're going to work with this FD line. I know my area really is 0.15. Now, the most common mistake. I'm organized. I labeled it as an area, right? Most students do not. They just write a 0.15 on their paper. And within 20 seconds, when they pick up their z-chart, they think that's a z-score. And they start looking up 0.15 z-score and they say 0.5596. And that is completely wrong. So anytime you have an area, if you want to go ahead and make it 4 decimal places to visually remind your eyes and your brain that, oh yeah, those are the areas. That's what I have to search for in the body of the chart. So we're going to go search for 0.1500 or as close to that as I can get because pretty sure you're not going to find that exactly. This is another one. Well, I already asked you to do this before you watch the video. I just looked at my answer key. I see another extremely common 1-point mistake you guys make. So if you did not already do this, right now, pause this video. I want you to go look that up and write down your z-score so you'll know if you're about to make a 1-point mistake. All right, 0.15. I assume you're back with me now. I see 0.1492. I see 0.1515. 0.1492, maybe I should write that in case I'm confusing anybody. He's the closest guy. And now, for those who are worried, I know this chart's really small. If you pick just the neighbor right next to it, I'm not going to take off. If you pick someone like an inch away, I am going to take off. All right, I lost it now. Yes. The z-score is negative 1.04. I knew it had to be negative. Now, let me point out the 1-point mistake so many students make. 1.04. So many students call this negative 1.4, or they call it negative 1.004. Neither one of those are correct. This is the z-score, negative 1.04. Remember, this is the ones, and the tenths spot. This is the hundredths spot. Okay, so there's my z-score. Here we go. See how all the thinking occurs before you ever get into the math. Here we go. Equals, I don't know what x is. I know the mean. I know the standard deviation. Now you have to do your algebra. Oops. That's the DF line, 43.36. I don't care if you call it 43.4. That is fine. All right, that's half the problem. But we get to cheat because there's symmetry here, right? So I knew that this line was negative 1.04. Then I automatically know this line has a z-score of positive 1.04. I know that from symmetry. If I just lost you there, you can do it the long way. Okay, you're not allowed to look up 0.15. You're going to have to look up 0.85. When you go look for 0.85, I promise you, you will get that z-score. Equals, I don't know what x is. I know the mean. I know the standard deviation. Do your algebra. 76.64 is the AB line. Okay. So, usually some students, after they do this problem, they send me an email because some students catch that there's actually another way to do the problem and they want to make sure it's okay. So I just want to say this real quick, just for that probably 10% of students who are truly understanding every little nuance of this problem. I personally like to talk about the symmetry with the z-scores. Negative to positive, right? Negative 1.04 to positive 1.04. So this is sort of an optional discussion here. There is symmetry in the x's. Like once we figured out that this was 43.36, remember that when we solved that originally? 43.36, that's an x value, right? You could then do subtraction. How far is 43.36 away from 60? I don't know, I'm going to estimate right now, approximately like 16 or something. And then you can add it to the 60, and lo and behold, you will come up with 76.64. So there is symmetry in the x values also, just from a distance standpoint. And we started actually seeing that when we were doing the easy empirical rule on test 1. Now, if I just kind of lost you there, you don't have to worry about it too much, but I know some students do understand it, so I wanted to talk about it. All right, so yeah, on this problem, knowing that there are two different answers, remembering that this is not a z-score, that it's an area, and that it's negative 1.04 are probably the three most common mistakes I see on this one. All right, let's keep going. I did number 9. All right, we're going to 12. Okay. Yeah, 12 is the most weirdly worded problem. And it was either part F or G of that miles per gallon problem when I taught you how to do this. That was weirdly worded. And that's why I did the problem in that past video, to help you with number 12. A machine fills containers with mean weight 16. So let me just kind of label what I got. If no more than 5.16% are to weigh less than 15.8. Wow, maybe I should just write that. No more than 5.16% are to weigh less than 15.8 ounces. Find the standard deviation. We've never been asked to find the standard deviation, right? You don't have to write this, but let's remind you of the z-score formula. Remember, there's 4 unknowns. As long as you can fill in 3 of them, you'll be able to solve for the 4th one. So I bet you on this one, we're going to be able to fill in those 3 pieces so we can solve for that guy. Now, see how they give you the area? I don't know if it's 5% or 95%, but I'll think through that in a minute. They give me area and they give me X. And remember we said what's most important is when they give you area. So we know that this is a working backwards, which means I got to be real careful and I better draw a picture to help me figure out, am I looking for 5.16% or am I looking for the opposite? All right, I know the mean. You know, this one's not as hard if you don't lose common sense. You know where 15.8 is. It has to be on the left somewhere, right? And anyway, no more than means less than 5%. I don't know if we're talking 4% or 3% or 2%. We're talking a little bit, right? So yeah, that's a little. And you might say, well, what does she mean by a little bit? Isn't that relative? You know, when I talk about a little bit or a lot, we're always comparing it to half the curve, 50%. Another extremely, extremely common mistake. 5.16% is 0.0516. You have to be able to turn percents into decimals. I saw those mistakes on test 1. I will continue to see them on the final exam. You are allowed a calculator. How do you turn a percent into a decimal? You divide by 100, or you just move the little decimal 2 places, whichever works best for you. Okay, I like this picture. It's a less than. So yes, my area really is 0.0516. Got to go get the z-score. This one looks like you're probably going to find it directly. 0.0516. Okay. In case you're struggling, it's about right in there. Z-score is negative 1.63. Negative. I knew I had to be negative, right? I crunched myself up, so let me rewrite it. That's my z-score equals. See, normally we don't know what the x is. No, I know what the x is. There's the x. I know what the mean is. There's the mean. Oh, okay, I don't know what the standard deviation is. This is probably the hardest algebra, which isn't that hard, that you're going to have to do in my class. So I definitely, because for those watching the video, you can't come up after class and ask me, so I'm going to talk you through the steps. But pause me right now. Try solving that yourself, then unpause, and if you didn't get it right, let's see. Okay, we're going to multiply both sides by sigma. You know, you might as well go ahead and figure out what 15.8 minus 16 is. So that should be negative 0.2. That is just my whiteboard. Sorry. Okay. Now you're going to divide by negative 1.63. And when you do that, you're going to get positive. It has to be positive. You can't have negative standard deviation. .1227. All right. Let's go on to 16 and 15. They're a little bit longer, but I'm not sure I'm going to do all the pieces, but I definitely will do most. I've lost my eraser. Okay. I think I want to do 15 first, at least parts of it. This was a whole footnoted problem, so it makes it look all long. This is words per minute. Number of words is normally distributed 60, 15. Okay. Part A, this is why I want to do number 15. You could tell I stole this from a textbook, right? Part A, the authors were really trying to make sure you understood concepts. You should not even have to pick up a pencil to do part A. But first, let me remind you of the picture. It's a terrible picture, but it will do, right? The mean is 60 words. What's the probability a randomly selected typist net rate is at most 60, less than 60? At most 60 is less than or equal to. Less than 60 is that, right? So that's what they're asking for. So the first concept that the authors wanted to make sure you knew is that on the normal distribution, it does not matter if you're including the equal to 60. And that's what I was talking about at the beginning of the video. When you're doing probability handout 8, these are two completely different things. It's critical that you distinguish between those two on handout 8, probability. But the normal distribution, these are exactly equal. So it's the same answer, whatever the answer is. And that's what they're asking. What is the answer? Wait, the mean is 60. Oh, you just want half the curve. 50% is the answer for both of them. They wanted you to know that the mean was in the middle, 50%. They wanted you to know that for the normal distribution, these two are the exact same answer. I'm going to skip part B. He's pretty basic, straightforward. You can do it and check my answer key. I think I want to do part C, but let me steal my answer key real quick. Well, part C is a pretty basic one, but sometimes the way different authors will ask a question confuses you guys. And maybe it's not my language, but I like to introduce you to other textbooks, and how other authors will ask questions. So part C, would you be surprised? That's a very generic question. So I can tell you this. I would not just, part C, if this were on my test, I would not just say, would you be surprised? I would put in parentheses, calculate the probability first, then you can give me your opinion, because that's all that is, right, on whether you would be surprised. So it's not just a yes-no question. You have to calculate the probability. Exceed 105. Okay. So 105 is up here somewhere, and it says exceed. Okay, so there's my picture. So x greater than 105. Can't work with x's, have to turn them into z's. You see I'm staying organized. I'm keeping my greater than symbol. Got to get the z-score. How do I do that? Subtract the mean, divide by standard deviation. This is 3. That's a z-score, 3.00. When you look that up, you're going to get 0.9987. I just looked at my z-chart real quick, right? But this is greater than, because how can that be almost 100% of the curve? It's not. Oh yeah, wait. I forgot to subtract. No, I didn't, but a lot of you forget to subtract from 1. It's a greater than. You have to do the 1 minus. Decimal form, 0.0013. Percent form, 0.13%, because that decimal is so small you may not be able to wrap your mind around it. 0.13%, that's why they asked, would you be surprised? That's like 1/10 of 1%. Sure, I'm going to be surprised. That is quite rare. That's all they were trying to get at there. I'm pretty sure I changed part D. Well, let me erase first. can't remember if I edited your handout 9 this semester. So in case I forgot, let me just, because it would take me too long to pull up Canvas to see what I put on there for you. It says 2 typists, independently selected. They kind of pulled a probability handout 8 issue into this handout 9. Don't worry about that. Just do, for part D, what's the probability 1 typist types greater than 75. Okay, just do the 1 typist issue. And when you look at the answer key, you don't have to worry about the whole squaring thing. Just take the beginning part of the answer key. And if that whole thing confuses you, 15D is not that interesting. You could just skip it. I really want to do 15E. All right. Suppose special training is to be made available to the slowest 20%. So when I was doing that video teaching you even how to do X to Z to A problems, I talked about this at the end of the video. So many of you on test 1 on the Z-score word problem, you did not pay attention to what the variable was. The variable for 15 is number of words. So I'm going to write that down there so I do not forget. Number of words. I know my mean is 60. Okay. And slow is 20%. So this is where you have 2 choices, because that's giving you an area and you have to know where's the boundary. Is the boundary here? Is the boundary here? I think I'm going to do this one more time, drawing my 2 colors so we can talk about it. Is the boundary there? Is the boundary there? Now, if you start thinking about numbers like 55 and 65, it's probably not going to jump out at you. This is where I love extreme examples. This is words per minute. Go with extremes. Go with like 5 and 500. If you type 5 words per minute, or if you type 500 words per minute, who's the slow person? Oh, the 5 words per minute. Now, I doubt the answer is 5. I'm just trying to get you to understand, how do you know that the boundary is over here? And it's a 20%, 0.2. It's not up there. The variable, you have to keep up with that. For number of words, here are where the slow people are. Because the slow people, just because of the word slow, S-L-O-W, does not always make it on the left-hand side. The word S-L-O-W is not enough information. I take the word slow and the variable, number of words. That's how I know where to draw it. Oh, I like this. See how all the thinking occurred at the beginning? I'm ready to do the problem. My area really is 0.2. That is not a Z-score. That is an area. So remember, if you want to make it 4 decimal places, to remind yourself, you are scanning the body of the chart. When you do that, you better come up with a negative Z, right? It's negative 0.84. And yeah, I don't know what X is. I know the mean. I know the standard deviation. I do my algebra. 47.4 is the answer. Makes sense. I knew I had to have a number less than 60. We're going to go on to number 16. Right, 16. Okay, this is time required to do an exam. Suppose that for the population of students, the distribution at normal with mean, okay, 45 minutes, standard deviation is 5 minutes. Part A. If 50 is allowed, so okay, they're giving me an X. Hold on. Maybe I should get a curve so I can... All right, they're talking about 50 being allowed, right? This is the minutes. If 50 is allowed, what proportion of students would be unable to finish? So, Han, they were not nice to you. They did not say less than 50 or greater than 50. You have to figure out, are they talking about less than or greater than? Who cannot finish? Well, if 50 is allowed, so kind of think, when I give tests in the classroom, I usually allow 50 minutes. Who cannot finish? Well, what about a student who takes 10 minutes? Oh no, they were able to finish. They left early and went and got coffee, right? Student that took 100 minutes, no, they were not able to finish and they gave me a half blank paper. So you've got to think through it, that these are the students unable to finish. The ones who took 60 and 100 and 120 minutes, right? It's a greater than area. Okay, so they're asking me X greater than 50. I know my final answer better be less than 50%. I know, of course, my Z-score is going to be positive. Z greater than, subtract the mean, divide by standard deviation. This is Z greater than 1. He's the only one I have memorized. It's 0.8413, but maybe I should not trust myself. And I think I wanted to point out something that annoys you guys. Oh, well. Let me look up the 1 first. 0.8413. But you're like, wait a minute, that can't be 84%. Oh, yeah, it's greater than. I have to subtract from 1, 0.1587. What I wanted to point out when I scanned this in using the Xerox machine, my paper probably got a little crooked. It looks like this is the answer to number 6. It was supposed to be 16 here, so that's the answer key. It's supposed to be 16. All right, but that's part A. I don't even think part A was on the answer key, so there you go. Let's move on to part B. Oh, I don't know why I just erased the whole problem. Time is normal. 45, 5. Okay, part B. How much time? So they're asking you for the X, right? Should be allowed if we want 90% to be able to finish. So this is definitely, they're talking about 90%. I don't know if I'm going to use 90% or 10% until I think about the problem, and they're asking for how much time. So let's think about it. All right, and this is kind of, what I do during a normal semester when I'm giving tests in the classroom. I want most of my students to be able to finish, right? Now, I know most students in general are going to take 45 minutes to be able to finish it. So how long should I give them so most of my class finishes? Again, go with extreme. Would it make sense for me to only give 10 minutes for my students to take a test? No, that's ridiculous, right? No one would be able to get past the first problem. Let's go extreme here. It would make a whole lot more sense for me to give 100 minutes, then probably most of my class could finish, right? So, I don't know that the answer is 100. We're just trying to figure out, again, does the boundary go here or here? Giving 5 minutes to take a test makes no sense. Giving 100 minutes makes more sense if I'm nice, and that's what this problem is about. We want 90% to really be able to finish. Here's your boundary. Here is the 90%. Oh, I like this because it's a less than, right? My area really is 0.9. Now, that's an area, not a z-score. So we're going to go look up an area of 0.9. Let's see the closest we get. 0.9015 is not bad, but 0.8997 is better. Just trying to be precise in these videos. That's the best guy, right? So, our z-score is, and I knew I had to have a positive z-score, 1.28. Okay, equals, I don't know what x is. I know the mean, I know the standard deviation, 51.4. That's how many minutes. And remember, that makes sense because on average, most students only needed 45 minutes, so I gave them an extra 5 or 6 minutes, you know, to take care of a few more people, so most of my class will be able to finish. All right, one more question, or part. And I keep erasing my beginning part, but that's okay. C. How much time is required for the fastest 25%? All right, they've given me an area. I don't know if I'm looking for 25% or 75%, so I'm going to draw my picture, and this is minutes. So you remember on number 15 that we did like 5 minutes ago? We had the slow people being down here, right? But remember how we talked about, it doesn't matter the word slow. Number 15 was about number of words. This is time, 45 minutes. This problem is asking for fast. So where are my fast people? If you did it in 5 minutes, you were super duper fast. If you did it in 500 minutes, you're super duper slow. So in this problem, what percent did they give me? Fast, 25%. Here are the fast people. On number 15, the slow people were down there. On number 16, the fast people are down there. So you can't go with the word slow and fast by itself. It's all about the variable. This is why the fast, when you're talking about minutes, is down there. All right, so remember this is an area, not a z-score. So again, you can put those extra 2 zeros if you want to remind yourself. You were searching, I mean, I better have a negative z, right? And I better have a final answer less than 45. You're searching over here for 0.2500. Let's see. 2483 is not bad. 2514 is probably best. So we'll go with that one. Negative 0.67 is the z-score. See, at this point, they all work the same, right? All the thinking occurs before the math. Equals, I don't know what x is. I know the mean. I know the standard deviation. 41.65 minutes. Yes, I was expecting an answer less than 45. All right, so if you redo the miles per gallon problem that I had done in the video before this one, and you do all of the problems that I've assigned from handout 9, just the ones I've assigned, right? And it's on the homework sheet. If you have forgotten which exact problems, you will be prepared to take these problems as part of the test. All right, so the next video we'll review probability, which is probably the hardest topic, and I'll just make a few comments probably on linear regression. That's the easiest topic, but don't forget to redo handouts 5 through 7 for linear regression. That should just probably almost be a quick review because it's not that hard a topic. Don't forget to review it, or you will probably have forgotten it because that was the first topic that we covered for handout 2. All right, see you soon.